So, welcome to today's class. Today we are going to learn Coulomb's law. What is actually welcome to today's class. Today we are going to learn Coulomb's law. Coulomb's law states that the electrostatic force between two charges here, two charges, one is Q1, another one is Q2. Obviously, these two charges here are representing positive charges, right? So, the product of two charges Q1 and Q2, obviously the very first portion of the law is saying that the electrostatic force is proportional to the product of two charges, and the second part of the law is saying that the electrostatic force is inversely proportional to the distance, square distance of two charges. Here two charges are separated by the distance of r. That's why the electrostatic force is inversely proportional to square of the distance. If we added these two equation, we could write down this way, like q1 and q2 divided by r square. If we eliminate the proportional sign, obviously we have to write down a constant. We are considering the constant is representing here is c, and obviously q1 and q2 divided by r square. Here, as I said, this c is nothing but a constant. If we keep these two charges within vacuum, in that case the value of c will be 9 into 10 to the power 9, unit will be Newton meter square per Coulomb square. C can be represent 1 by 4 pi epsilon naught. So the equation can be represented 1 by 4 pi epsilon naught. Obviously this epsilon naught is nothing but absolute permittivity in air. As I said, these two charges kept in a air medium, vacuum medium. That's why this is the absolute permittivity in vacuum. And then Q1 and Q2 divided by R square. Now, as I said, the equation I'm write down here, naming equation number 1, where these two charges are kept in a vacuum medium. That's why epsilon naught is representing the permittivity in air. If we keep these two charges in some other medium, then we have to change the equation like 1 by 4 pi epsilon. It means this epsilon is represent absolute permittivity in any types of medium. We don't know exactly right now. I'm just saying any medium. Then obviously charge will be unchanged. That's why Q1, Q2, and obviously distance also be unchanged. Now, if we solve this two equation, we can write down F by F1. If we solve this two equation, writing straight away. So this is epsilon, and by this this is epsilon naught, obviously this one. So this one equals to, we can write down epsilon r. So what is exactly epsilon r? Epsilon r, or sometimes you can find out in some book is written k. So this epsilon r, and or this K is nothing but relative permittivity or specific inductive capacity. We can define this relative permittivity is nothing but a dielectric constant of a medium in which two charges are placed. So we actually comparing uh, some medium where we are placing here these two charges, and previously we are placing in a vacuum. So we are just comparing these two medium. So this is epsilon r is nothing but dielectric constant of a medium in which two charges are placed. So in conclusion, we are finding